So let's solve an equation with radical expressions. So say I give you the square root of x plus 7 is equal to the square root of x plus 1. Now, since both sides of the equations contain a radical, there actually is no purpose in moving the square root of x to the left side or moving the square root of x plus 7 to the right side. So we should just leave it as is. Now, in solving, the first step you should do is square both sides of the equation. And I want you to notice the difference between the left and the right side. On the left side, the whole thing is under the square root, so when you square it, it's going to cancel out. And on the left, it's just going to give you x plus 7. But on the right, the square root is only encompassing the x. So this is actually going to look like how you would FOIL, right? So this is going to look like square root of x plus 1 times itself, square root of x plus 1. And then you would do the FOIL method. So from up there, let's see if we can do it. So first term is square root of x times square root of x, which is square root of x squared. The middle term is going to be 1 times square root of x. Then the other middle term is going to be 1 times square root of x, and then the last term, the last term, 1 times 1, is going to be just 1. So simplifying it further, we get x plus 7. X plus 7 on the left, and then here the square root of x squared is just going to simplify to x. And then these two terms, since they're like terms, they're going to combine and become 2 times the square root of x. Again, you can think of them like variables in themselves, where you can combine like terms. So we're going to get 2 times the square root of x here, and then the last term is 1. So now we can subtract and cancel out things. So we have an x on both sides, so if we subtract an x from both sides, these terms actually just completely cancel out. So what we're left with is 7 is equal to 2 times square root of x plus 1. Now we want to solve for x, so we want to have a situation where we have x is equal to some sort of number. So the next step would be to move all the coefficients, all the constant terms rather, to one side. So if we subtract both sides by 1, then our new equation becomes 6 is equal to 2 times the square root of x. And now we want to solve for x, so what do? We square both sides again. So squaring both sides again. On the left, we're just going to get 6 squared, which is 36. On the right side, the square is going to distribute to each term, so this is going to become 2 squared times square root of x squared. So simplifying further, we get 36 is equal to 4 times square root of x squared, which is x. And so now if we want to solve for x, let's divide both sides by 4. So we get 36 over 4 is equal to x, and 36 over 4 simplifies to 9. So we know that x is equal to 9. So that's our solution. But remember, we actually ended up squaring the function not once, but twice. So when we square the function, even if it's just one time, we have to check our solutions to make sure that they solve the equation. So you want to check by plugging in x is equal to 9 into the original equation, which, excuse me. So you want to plug x is equal to 9 into x square root of x plus 7 equals square root of x plus 1. And you want to make sure that there's equality there. So let's do that. So you want to check whether the square root of 9 plus 7 is equal to the square root of 9 plus 1. And remember, if I put a little question mark over the equal sign, that means that I'm not asserting that it's true. I'm just checking to see. So 9 plus 7 is 16, so we want to check whether the square root of 16 is square root of 9, 3 plus 1. So we want to check 4 is equal to 3 plus 1, which is 4. And as it turns out, it's actually true. So on that last line, I can leave a little question mark out because we know for sure. So x equals 9 is the solution to the equation.